Okay, everybody. For those of you who are watching this on the recording later, I'll probably not actually get into the deep bits of what we're doing for another 10 minutes or so. I'm going to give people a chance to hop in. And if you are watching it on Twitch immediately, which is twitch.tv/tannewt, which is mine, um, let me know. Just drop me a comment and say that it's working for you. I'm also in the Discord, and I'm in the voice chat in Discord. Um, so, yeah. Um, yeah, so I guess I just want to wait a little bit. I'm going to, in the stream, I'm going to talk about a couple issues with the CircuitPython memory allocation stuff. They're kind of like the deep end of CircuitPython stuff, but yeah, we're going to do that. I was playing around with getting the tools going. And so I'm going to play around with that a little bit more before we get into the deepest bits. Don't know. Trying to figure out what all these numbers are. If anything ends up behind me, let me know. Which is why I'm in the voice channel. If you want to give me quick feedback and I don't see it, you can just hop in the Discord voice channel to tell me. Hey, we have 5 viewers. That's about all, probably all I'll have, so maybe I should just get going. Is there anybody else we're waiting for? Mr. certainly has a pickle. All right, I know Jerry has to get out of here at some point. So maybe I'll just get going. Oh, now I only have 3 viewers. Oh, I could just tell you how many viewers I have the whole stream. Wouldn't that be exciting? I know what I should do. I should pull up a video. That I can play. All right, cool. You should be able to see that. Okay. Let me drop a marker and and beware that if you are in the voice chat like Jerry is, you'll hear me probably before you hear me on the stream, so you'll want to pick one audio source, not both. Oh yeah, I can hear it echoing. Cool. Yeah, you could just mute me in the Discord voice channel until you have a question, pop in and then pop back out if you want. Perfect. Okay, let me. It looks like I can drop a time code. Doing today. 5 minutes in. I added a stream marker. Okay, so quick about me. I'm Scott, and I go by Tannewt online. I'm sponsored by Adafruit to work full-time on CircuitPython, so I've been doing that for 2.5 years. CircuitPython is a embedded version of Python that runs on lots of different hardware devices like this one, and a bunch of others that I have on my desk here. It's based on MicroPython, so we didn't do a lot of the hard work, which is actually getting Python to run on these small embedded class microcontrollers. They're typically like 40. The lowest end we support is 48 megahertz, upwards of 120 megahertz. RAM wise, that's like 32K RAM up to like 192, 256K RAM. So RAM is what we'll be talking about today. So the motivation for this is that there's a couple issues that have come up. We're towards the tail end of our 4.0 development, and as we get to that very end of our 4.0 development, we're moving into a phase where we want to hunt down the bugs that we have outstanding and try to fix them. That will mean that like once we figure out those bugs, we can feel really confident that what we have is stable. So in particular today, I wanted to kind of take a break from all the display work that I've been doing and really focus on a bug that there's two bugs or two issues that people have filed that I think are related, and they both have to do with the long living that we do in the CircuitPython heap. This is not something that MicroPython does, although I've talked to Damien about it. Maybe at some point once we figure out all these bugs, Damien will pull it upstream into MicroPython. So first, let's just talk about the bugs, I guess, and then I'll give some background on Longlived. So the first bug is this GC Longlived relocation problem. Notro has done a lot of great work, and if you read down onto this, the bug number is a 1218 if you want to follow along. But Notro's done the work to say like, hey, if I do class logger pass just to create one, and then I do root equals logger and then logger.root equals root, these two things are now different. The class level thing and the top level thing, or the local. And if you print them off, they're objects at different areas. So that should not be the case. I was just thinking about this and I have an idea what it is. So these are two issues that are related to long living stuff. And I have a feeling that I will... I have an idea of what the issues are. So hopefully in this stream, within a few hours tops, I'll be able to actually figure out what the issues are and get them fixed. So you can see here that Notro actually did the work and just disabled the make long live stuff, and then it worked just fine. So clearly it's something having to do with long lived, which I'll go into in just a sec. And then the other thing is Cubist filed this issue saying like, this is really weird. I'm trying to play some audio and it works fine unless I try to define a class in the middle of my stuff. It gives some details about what version and what the sample is and blah, blah, blah. Dan says, it might be related to that long-lived thing. It's not clear that global dictionaries are doing long-lived exactly right. Some other issues. Yeah, so those are the two issues that I want to kind of try and tackle today. Let me take a step back and talk a little bit about what long-lived is. So I don't know if I have... I was thinking if I have a picture. So the heap, there's typically in C software, there's typically two kind of areas of memory that you're managing. Now, if we take a step back, memory is typically RAM, where a byte is addressed by a number, right? So that number is known as an address, and you can say like, hey, give me the value that's stored at this address. And then the question is how do you manage the memory? How do you manage where all of the state that you need, all of the bytes that you need to store live? So there's two places you could do that typically. One is called the heap, which is just a general area that you have some data structure that keeps track of what you're using and what you're not using. And then you kind of intermingle stuff as you need it in that area. The other area is called the stack, and the stack is all of your local variables as you call functions. So if you call a function, it'll push values onto the stack, and the stack tends to grow downwards. If you don't understand that, it's fine. Let's just move on. This is the deep end, so don't feel bad if you get a bit lost. So we're going to talk about is the heap today, and specifically not the C side. So the C side of CircuitPython, we basically allocate everything statically, which I guess I didn't talk about, but basically when the software is actually compiled, all the globals and stuff are just like, we're going to need that forever in RAM. And so that actually lives below the heap. So you'll see like all the statics, the heap, and then the stack, if you look like from high to low addresses into RAM. And so what we're doing today is looking at how Python objects, which are really just C structs under the hood, are allocated. So when you create a new object, whether it's a dictionary or whatever, where in that memory does it get allocated as we go along. And the typical way that, let me just check to see if anybody has questions. Nope. So the typical way that MicroPython does it, or how they did it when we started, was that MicroPython basically takes that heap area that you tell it to use to manage, splits it up into 16-byte chunks, and then keeps track of which of those 16-byte chunks are being used. And if a 16-byte chunk is not being used anymore, it will mark it as free and be able to place something there later. And it does this mark and sweep style thing where it has a list of all of the blocks and whether they're used or not. And then if it needs to allocate something, it just scans that list until it finds a series of blocks that are all free, that are large enough to store what you're looking for. And then if it does find that, then it's able to it'll mark those as used and then return that address pointer to you. If it's unable to find that, what it'll do is it'll go into a collect phase, which is basically, let's figure out all the stuff that's no longer used and we'll mark that as free. And then we'll see again, can we actually allocate the thing we're trying to allocate? And the way the collect phase works is that it looks on the stack for all of the pointer values that might reference things into the heap, and then it also looks into a few static areas to see that, and then also the heap itself. So anything that's on the stack or on statically allocated that references the heap, and then everything that those things reference are kept. So the thing is that as you do that phase more and more of just like, let me fill everything up and then clear out the things that are gone, what you'll end up doing is actually getting like kind of a Swiss cheese. It's known as fragmentation, and basically the idea is that although you may have like half the heap free, because all of the things that are still there are evenly spaced apart, the amount that you can allocate consecutively might be a lot less. And one of the ways that we're trying to solve that in CircuitPython is by doing just long living. So the idea with long living is that there's really kind of two classes of objects. There's the ones that you create, you use for a little while, and then you're done with. And then there's the things that are like, once you allocate them, you know they're going to be around a long time. And the idea with long living is that we can put all of the stuff that is going to live a long time next to each other and really make it more dense than if we intermingled that long-lived stuff with short-lived stuff. So I pulled up, I made some videos a while ago when I did this long-living heap stuff. So let's just see that. And let me know if I need to go over something again. Let me see, can I change the playback speed a little bit? I don't know. I know I can step through it. So what you'll see here is this is a visual representation of the heap itself. So, and this is after I did some long living. So on the left-hand side is going to be all that temporary stuff. And if it's gray, it means basically that it's like dead or is going to be cleaned up at some point. And then the stuff on the right-hand side is what we've determined is long-lived. So far, what we have here is this orange box is the Q string pool, and then it points into the lighter orange box, which is the actual strings. Now, this is known as string interning, so basically deduplicating all of the strings that are used in user code in CircuitPython. And MicroPython does this too. So let me just play it through. And you can see that the static long-lived stuff grows and grows and grows. And then when they meet each other, you'll see. So now we've started, I just pause it. Now you see that there's holes on the left-hand side that are coming. This is as we're collecting the stuff that's no longer allocated, we get those free holes. And it's important to note that you'll notice that we don't actually move any of the stuff that's left on the left-hand side. It's left where it is. So, and then you can see now that the collect is done, it's allocating again, kind of intermingled with that. And all these arrows are pointing to how everything references each other. This is just some video I generated a while ago. I don't know, like I don't think the behavior anymore, because we took some time to figure out like, oh, if this thing's on the left-hand side, it really shouldn't be. Let's actually move it along with stuff. So I won't generate any of these videos today because they take a while. Basically, the way they work is I hook up the debugger, and for every time we allocate or free something, I take a snapshot of RAM. Now this is really nice because it's 32K of RAM, so I can literally just store all of RAM every time, which is cool. But yeah, so that's the general idea with Longlived. I'll play it one more time. This is a little old because there's definitely stuff that we long-lived now that we didn't anymore. And the idea is that the height of the blocks represents how much memory it is as well. So I won't be making any videos today, but I have actually polished off the script that that produces the like individual frames. It's literally just I dump a bunch of PNGs and then I make an MP4 out of it. So that's how I did that. So here's the one that I just grabbed. Well, sorry. Here's the one that I just grabbed now. The reason it's so much bigger is because this is the heap of an M4. And it's like a very basic, very, very basic code.py. So the code.py here is just like literally like print something and store a number. So if we look closer here, I forget what gold is. I think those are dictionaries. And then on the right hand side, we have the QString table, which is this, the orange bit points into the light orange. So you can see that from the code.py that I ran, I loaded the string code.py, and I also loaded the string z, which is my variable name. So there is tricks to make shorter variable names to save memory if you really insist. But reusing names also works well for that. And then we also see this pink box that's not quite aligned right, is the contents of the string that we print out. So those are reflected one for one in memory as well. And then the other view that we have, so this is like heap layout. So this can show us like long-lived versus not long-lived. The other thing is I actually have like an ownership graph. So this shows how objects relate to one another. And this is what is used when stuff is deleted. If nothing points to something, then in theory it should be deleted. So over here we can actually see that this NP state context, this is like the top level set of pointers that MicroPython keeps a hold of. So anything that this points to directly or indirectly is always saved. You can see that the VM last pool, which is the pool of Q strings and then the strings of it itself. Over here, I know that these light green ones, they're actually functions or raw codes, but basically they're functions. So this is actually pointing to two things. It's pointing to this is my code.py loaded in memory. And this block here is the actual bytecode that it will run for it. And then the right-hand side here this is what MicroPython calls a const table. Basically, things that, like objects that the raw code, the bytecode can reference based on an index. So you can see here that like it's referencing what we're printing out. And then this is our main dictionary table. So this is you'll find out that basically everything's a dictionary in Python. It's both in Python and in MicroPython. And so this tells us that like we have a variable time, which is actually a module, and we have a variable z as well within our main dictionary. And these other things aren't very interesting. I'm not sure they're exactly correct. But yeah. So that's kind of the two tools we have at our disposal for inspecting the heap. And what I did actually here is I took the heap snapshot from the debugger when the time.sleep hit. So let's jump into debugging. Let's start, since this plays audio, I don't want to worry about that quite yet. Let's start with Notro's example. Now it's done in the REPL here, but it should be really straightforward to just switch over. So what am I doing? So I had JLink running with GDB. Info breakpoints. Disable. So what I'm going to do is I have a USB cord hooked up to my Metro that has a button I can press to have it connect and disconnect to my computer. You don't want it connected to your computer data lines when you break because your USB bus will become really unhappy. And if you're like me and you listen to music over USB, your music will start to stutter and you know things bad. You know bad things are happening. And one thing I haven't done yet, but I do like to do, is I like to break into the reset into safe mode. This is basically if we hard fault, which is like if you do divide by 0 or null reference or read memory you're not supposed to read, you'll hard fault. So always having that is nice too, because you can get a backtrace usually if you break at reset into safe mode, which the hard fault handler will call. So I have this macro or thing in my GDB that allows me to reload debug, which is rebuild everything and load it. So, and reset. And then I'll just run. And I leave the reset into safe mode breakpoint on. And so I just clicked it and now it should pull up. Yep, and I think you can actually see that it showed up there. That's what this drive is. I don't actually click it that way. I have the code.py open here, so now that it's mounted, I can just modify it. So let me just copy this. Paste it here. This is why when you file issues, it's awesome that you create the smallest test case possible, because then it's easy for me or somebody else to come along and replicate it. So I'm going to save that, and I don't think it crashes, which is good. Let's connect to screen and print. Oops. So we can see here that we do have two logger objects at different areas, which is not good. Basically, there's a class of bugs with this long-lived thing where we construct everything in that temporary area, and then at the very end we say like, oh, we actually want that longer, so let's move it over here. And that, if it's done wrong, if you have two references to that thing but you only move one over, you can end up with two copies. And that's what you're seeing here, is that we have two copies of logger, which is not good. So let me import time again. And this should pass just fine. So now I'm gonna quit out of screen, and I'm gonna eject. So I'm gonna, before I enable the breakpoint, I'm gonna disable the USB. So disable the USB. Now I can enable breakpoint 1 again. Reset and continue. Let me see if, oh. Block select. Sagittac is asking what is on my shelf behind me. Commodore 64, and then 2 down is an Atari 800. Neither of which have I tried to turn on. But I will at some point. And then they'll run CircuitPython. Yeah, I'm not the fastest editor person in the world, but Sedacious is telling me block select. I'm like, yeah, you're right. So now I run it. I've broken at the time sleep, so I know that all the logger stuff's happened, but the VM is still running. And now I'm going to go back in my history and do this dump. And it's, sorry, there's a bug in GDB, but this is the command it actually ran. It gets shifted over wrong sometimes. So what I just did is I wrote out from S relocate to E stack, which is basically all of RAM, into the memory, or into this file ram.bin. And then if I go here, I have this tools analyze heap dump that is in the CircuitPython repo, and you give it the ram.bin, the firmware.bin, so all of this, the stuff that's available in Flash. You give it the firmware elf map, and then you can tell it to draw and print some stuff. So I'm gonna run that, and it had one warning, but let's take a look and see what it looked like. So let's load up the new SVG, and we'll load up the new memory layout. So not much here, not much helpful. And then again, not much not much helpful over here. But it is kind of interesting to see that there's two different, like, everything's still kind of connected together. So let's see how it's connected together. Maybe we'll make more sense of it. And the blocks, the block coloring and stuff should match here. So that should make it easier. And again, I haven't looked at this. I just got the tools going before I started this. So this is why it might be a long stream. So again, we have the key strings that we expect over here. We now have, I bet that this is code.py still, right? And then this is referencing some raw code as well. And it's referenced from here too. So I bet that this little chunk is the pass within class. And it is interesting that there's this reference and this reference into that class function. So we might want to take a look at that. And then if we go over here, what happens is when I think a class thing actually is first a function, and then the contents of that function are run to create what is called a type object. And that type object is kind of the same synonym for class. And so what we can see here is that within our main top level dictionary, we have root, which is a pointer here, and then it points here. And we also have logger, which is a pointer. This orange, I think, is a type object. And then that type object is referencing a dictionary, I think, which is what red is. And then we can see that root points to something else. Which is weird. Let's go up and look at the... Did I save it? Oh, it went away. I should have saved it. Because the numbers that you see when it prints out an object are actually the memory addresses. So I have a feeling that this root is this number, and the other root was this number. Which is weird. So the other thing I want to do is I have a feeling I know what this is, because I think I changed. So there's 2 points that I want to long live something. One is I just did an import. Like I just imported a module, and in practice, you can't really unimport modules. So I just want to long live everything that I import. So that's one place that I want to do that. And then the other place that I was thinking I would like to long live is that when I create a class, I kind of assume that will be around a while. Now, it is important to note that if I choose to long live something that isn't actually long lived, that's actually not the end of the world, because the long livedness only impacts the allocation of stuff. It doesn't actually impact when it gets deleted. So you could potentially end up holes in the right hand side if we accidentally long live too many things. But what I have a feeling here is when I was doing the class long living, I think what I did is I made an assumption that Notro with this example is breaking. And that assumption was that attributes on a class are only set when you're kind of creating the class. And the problem here is that I'm setting it after the fact. And so I think what I want to do is I should be able to say oh, is the type created, long live everything. And then later on, if another attribute's added, it just won't be long lived. It'll be referenced from long lived, but it won't be long lived itself. So I think that's what's going on. So let's dig into the deep end. Where does this code actually live? So it's in so this is Atom. It's the text editor I use. It's highlighting it based on files I've already changed. I had to change some DHCP stuff for a warning, which is annoying. But today I think we'll be looking mostly in the py directory, which is very much MicroPython code. We haven't changed a whole lot of this. The long living stuff is the thing that we've changed the most. So actually what we could do is we could search for it. So these are kind of the top level things that you can call to make something long lived. So let's just I'm still on my rotation branch, which I've Dan actually merged in already. Okay, so these are the spots that make object long-lived is being called. It's being called here, which is object type, and it's being made in PyExec. So I think this PyExec one is, it says module function equals make long-lived, which must be when you import a module. So let's, object type is much more related to what we're doing. So let's take a look at that. What line was it? 1068. Silver Searcher is pretty fast still. It's clearly not my bottleneck. I think that can get people hung up actually, like, oh, I don't type fast enough to be a coder. Well, it's like, I switched to like a funny keyboard and a different layout and I'm still a coder. So that's just one part of it. Okay. 1068. Long-lived. Oh, look at that. two lines up, it says store attribute. So let's figure out where we are. We're in type attribute. So this is saying, like, if we're storing an attribute on a type, we're storing something on it, let's long live it. That seems bad. That seems to explain the behavior we're seeing, doesn't it? So I don't think, yeah, this is what I kind of like in the back of my mind I was remembering. So how do I undo that? Let's just do this. That actually makes me wonder if we should long-live types at all or not. I was actually kind of surprised when it would be kind of interesting actually. Let's just before we see if that fixes it, let's break on that and just see when it's being, or like where it's being called from. Yeah. Okay, so this is where it's called. Fun VC call. Execute bytecode. Store attribute. Yeah, so I think this is what's screwing us up. What I would like is if I could long live it still. So the question is like, when does the type get, when is it finished, basically? Oh yeah, and this is long-lived as well. So the object itself is long-lived. But if we put a function in there, we'd like it to be long-lived too. All right, so let's play around with this. So, okay, we don't need that anymore. I Save the file. This problem is that I'll probably want to add something to the code.py. Let's just take a look at the layout now if we change that. Oops. I upgraded it to like new graph viz and it goes way faster. Six keyboards, adjust macros. Oh, I guess I should have saved that older version, shouldn't I have? Looks pretty similar. There's no dangling thing here though. Right, like there was another one coming in. Now we can see that, oh yeah, look at that. So again, from our top level dictionary of variables, we see that we have logger and we have root. Root points here, which points to, so this must be the instance of logger. And then this is the class. And then this is the dictionary. So red is the top. A dictionary is two parts. It's the dictionary itself, and then it's the table of entries in the dictionary. So the red part is and they're allocated separately. The red part is the dictionary, and this gold part is the table. So we can see now that correctly, this root points up here. So when root was not pointing there, I think it must have been pointing over here. That was the long-lived one that we copied incorrectly, as it turns out. I actually wonder if in this view it would be really nice if the addresses were bold if they were long-lived. That would be pretty neat. Because then we'd be able to see like, oh, this whole hierarchy is all long-lived. How long will it take me to do that? I don't think it'll take me that long. So the way that the allocation works is that it knows the lowest address of something that's been long-lived. So if I could read that value and just compare, I would know if it was long-lived or not. Let's just see. It's been a while since I did this. I think it's actually in GC. Welcome to the deep end, everybody. It is really fascinating. Like that's done as an optimization. There's another optimization here so that like every time you need to allocate, you don't necessarily have to seek over a bunch of stuff that's already been allocated. Oh yeah, so there's GC state mem pool start pool end. Let's just say, let's look for long. Yeah. MP state mem GC lowest long lived pointer. So if we go, I was printing stuff out. I think it's in this. MP state context mem. And I don't want the address. Dot. GC lowest. Oh, that is what I want. Let me just get the address of it. So MP state context 272. So if I go into my analyze heap, we could actually cheat it just to see if we get what we want. For block. Font name. Let's just first see if we bold that, if it still works. Do we bold everything? No, we bold nothing. That's why. That's why I did that. Is this bold? Is that bold? It kind of looks like it's bold to me. You know what? We could probably change the color. Oh! Let's see, where are we? Background color, gold. Map element blocks. This code is terrible, by the way. I wrote it, I could say that. String blocks are hot pink. Oh, it was only string blocks I was doing that for. Bytecode blocks. Background color. QString chunks. Bold. See if that does something. This is thrilling, isn't it? I know. Me talking to myself. That looks bold. There's unbold. Bold. That's terrible. That's really hard to see. Oh, I wonder if I could change the color. Font name. Who wants to guess that it's font color? It's probably not. Welcome to my brain. This is how I work. Ah, there we go. It's both white, but that's okay. Font color worked. So let's see. This is one big function, which you're definitely not supposed to do. Let's just hard code here. Long-lived. Start equals. This. Ooh, we have 9 viewers. It's gotta be a record for me. I don't know. All right, where did my white go? Oh, look here, type colors. I guess I could just search for it. Part of me thinks that it's useful just having it like... Here we go. If... block... I think that's what block means. I think it's the address. You know what? I think this will make some. I wonder if we could do gray instead. I'm just worried that if the background is white, then we're not going to be able to see it. We could make it like blue or something. I don't care. I know, right? The Atom autocomplete. I was thinking about trying VS Code, honestly. Atom's been really slow. I'm on beta, to be fair. But, oh, gray is worse than white, for sure. I think I'll just make it blue. Blue. Ba, ba, ba. Where's the generic one? That's what I want. Like the one that does these blocks. Type colors. Where are you used? Here we go. All the cool kids are doing it. I have a feeling VS Code and Atom will merge at some point, given that they're owned by the same company now. Okay, in this is there a font anywhere here? No. Let's go copy and paste it. This is where scripting is so fun. Like, let me just copy and paste from here to here to here to here to here to here. And I think it's Word. No, there's Word and there's address. Let's try address. Do we have any blue stuff? That one turned blue, which is good. Oh, this one turned blue as well. Blue. Blue's not a bad color. Oh, you know what we should do? We should make it pink. Pink's gonna be easier to see. That's not the pink I expected. I expected hot pink. What the heck? Is hot pink a separate one? Oh, putting it on strings is gonna be bad. Pink. Let's make this one. Oh no, it is regular pink. Okay, we'll put hot pink on. I know. I'm using Chrome and Firefox right now, which I don't usually do. Chrome, I found a really good Chrome extension for viewing SVGs though. That allows me to pan. So that's what I'm using it. It's probably really disorienting when I do that, but fuchsia? I could do fuchsia. All right, I think we're set. So this is kind of interesting. This is interesting to me here that this is not long-lived, but this and this are. Because this is the const table, I think. So this is your code.py, so anything in the code.py I would expect to be. Although at the same time, the class raw code itself you're not going to run. Anyway, this is... I am not here to fix all of the long living stuff. Okay, so this is kind of what we expected. The instance is not long-lived. The main dictionary is not long-lived, which is fine because, or the main table is not long-lived, which is fine because this is going to grow, and so we're going to end up reallocating it. Yeah, it could be long-lived. That's right. But my color coding might not cover everything. I don't think I missed anything. It's possible. I mean, it was 2990, and this is... We can do this ourselves. We know what 2990, right? So that is not correct, right? What was the number I did? 299F0 is what it said. 299F0 should be higher. So yeah, it should be long-lived. So where did that go? I think we don't need it there. I think this is... So it's doing like a linear scan, and this is the point that it's actually past the start. It's reading the type. In the struct that represents objects in the heap, the first word is a pointer to the type of the object in MicroPython. So this is reading that word. It's saying, is it in ROM? Right. So this would only work if it was under here. It would only work if it was in ROM, which is not what we want. Okay, let's ba-ba-da. Somersault for the win. So now it is. Now we see it as long-lived. It was just not pink. And then here we see that the dictionary itself is long-lived, but the table is not, which is kind of interesting. I wonder if let's try this. Ken has an internet. I don't have an internet to give you one. Otherwise, I would give you one. Let's move our sleep after we create the class, but before we do the weird root logger stuff, and just see if that map entry table is long-lived, because I'm curious to see if type and everything below it is long-lived. And let's add a function in there too and make sure that it gets long-lived too. All right. Did you have you noticed that my habit is to write git status whenever I go to the command line again, even if I'm in GDB? I'm like git status, git status. I'm like, no, I'm in GDB. It's the wrong, not what I want. Okay, so info breakpoints. Disable one. Turning on USB. Code.py. I'm gonna print say hello all self print hello world. Putting strings in functions is handy because then you can see it. So I'm gonna actually, you know what I can do is I can put two sleeps. And now I'm gonna eject it and turn off USB. On reset. Enable one. Continue. I don't know what that was. And then find my dump. Run this again. So now we should see the new function and we should see if it's long-lived or not. What is this? Oh, this is the video. Or no, that's preview. Let's quit that. Whoa. That's quite different. Ah, see, this is interesting too. That there's a little stuff kind of out here on the non-long-lived side, even though that maybe they should be. We successfully got our hello world and our, I assume this is our, oh, that coloring is wrong. If it's over here, it should definitely be pink. So let's look at this again. I added something right beforehand that like all these pointers to stuff on the stack. It's kind of interesting. So I think that things like this will go away on cleanup. Which we could add a GC collect there. But like this is an extra copy. (298F0). Oh, you know what? My long-lived pointer is wrong now because I hard-coded it. That's not fun. It's MP state context 272, which we could automatically load if I wanted to. Or I could be lazy. I really should. This script is not the most automatic thing in the world. People are like, can I help debug the heap? And it's like, yeah, but this script is not the best. Because there's a section here where it's a bunch of state context stuff. And like the layout of the state context changes every time you change it, which makes it annoying. So where did I put the hard-coded value? Right here. It's all about balancing time versus getting what you need out of it, right? So I'm getting emails. Look at that. So it does look like we're long living more for sure. It's interesting that this stuff is only referred to from the stack. I should have added a GC collect. Because if it's going to get deleted, we don't really care. What we care about is that if it gets copied over. Anyway, it looks like logger itself is being long-lived down into including its functions, right? So we can see that like this is the type, this is the dictionary of stuff in the type. Hello all is, or the table itself is long-lived. The hello all got long-lived, and the hello world string that we made hot pink along with the hot pink background is also long-lived. Now this is interesting here that is long-lived because it's just that must be our code.py. That's probably what it is. Anyway, so I think this bug is fixed. Did we actually confirm that it's fixed? It looks like it's long living, the type, which is what we want. And I was about to git status. Long living. My brain is starting to fail me. Look at that. They're the same. Hooray. So we were over eagerly long living it. We never did figure out what these are. Oh, but you know what? We also haven't collected yet. Let's just do that just to see. So if you want to run, I'm going to do a time sleep. 3.1 GC collect. That's in case we want to collect it, if we want to get the RAM dump. All right, I ejected. So we're gonna break, oh, if I turn it back on, we're gonna break once and then we want it on the second time. And our long-lived pointer is gonna change. I really should just figure out how to read that. It looks the same. Let's take a look. There's definitely less, but there's still there. It's 2CB0, 2F10. They could be referenced by the stack still. Let's see. Yeah. 2CB, 2DF0, or 50. 2BC, 2D50 is here. Oh, this doesn't look great. I don't know what this is. Const table? Yeah, that must be a const table. This is a copy of this. Oh, there's bugs. I wonder what this value is. If this is a... This looks like a function to me. I don't know why it's not getting colored like this. Yeah, take a look at what it is in GDB. I can look in GDB. The other thing I can do is I can modify the visualization script to dump it out. Since it's also just going over RAM. Doesn't matter. I'm not sure it matters. Actually, I mean, if it's going to be long-lived, long-living these three things would be nice. (2002) 99C0 99B0. All right, let's go with what Sagittag is doing, suggesting. npobj t 2002 99B0. Do I want to just read it? Let's see what it points to. That's helpful. BE4 CCCCE. That's weird. 2. It seems like it feels a little misaligned to me. Weird. Let's take a look at 2002 99A0. And that's going to be a function type. here? Or is it in here? Yeah, this is what I want. That's my guess. Globals, bytecode, const table. 2002 99B0. So that's the pointer. And extra args points there as well. But we don't know. It's like the length of the const table is like defined in the bytecode, I think. Do I do anything with it in here? Nope. Function types, plural. Ah. Now it's weird to me that this thing doesn't know what it is anymore. Or I don't know what it is. C0. This could be a different function type that I don't know about, which would mean that I don't go into the const table anymore. That would make sense. What was the 299 C0 2? That's what it was. That doesn't seem right. What is E0? I don't know why it does that. Oh, that is interesting. Why is type 2? That seems wrong. I have an idea. That doesn't seem right. We should be breaking somewhere. Me try to be clever. Maybe the type is just... I wonder what this looks like before we do the class thing. Like after we've loaded it, but... Let's do another sleep. Like super early, like right at the start. Oh, I guess I can't do it before import time. Okay. There's a light on my USB cable that tells me if I'm connected or not. I think this bug is because I'm using fish, I'm not bash, which I really like. Okay, there's fewer stuff. Ah, it's still not highlighted. Interesting. I mean, that's definitely what it is. Like, this is definitely a function pointing to bytecode and a const table. The const table has another function. So this is like, it hasn't passed it off yet. This is the hello world. Ooh. That's so strange that the type is 2, though. Is that still the case? No, I don't want to watch it. That's C0. Weird. Oh, thank you. I didn't even realize I sneezed. I'm in the zone. It must be something that... Like, this doesn't look right to me either. That globals is... D0. This, by the way, is not fixing the bug. I think the attribute bug is fixed. But it's interesting to me that I should be saving this. Like right now, it's not long lived. It probably should be. That's so crazy to me that the type is 2. Like, if I MPY'd it, it would tell me. Like, the way that the MPY is being packed into. Yeah, I know. I don't. There's no way it's 2. It's got to be something with. Like, it's got to be in runtime. Like, runtime calling a function from the const table. And then it knows because it's calling it that it's of a certain type. Which I guess makes sense given that you wouldn't want, like, if it wasn't an MPY file, you wouldn't want to be referencing like the address of these function types, which is what you would do after you load it. Right, because the only thing that gives, yeah. It's not a native function. Prepare code state. PC call. It's gotta like fix it up. I'm just curious. This is bad. It's not assembly. You know, maybe it's like a raw code. That's probably what it is. Persistence code. Where is MP raw code defined? See, because this bytecode prelude has more information on it. But this type of object is actually what it is. I don't think it's a proper function yet. It's just raw code. It's an emit glue. That was obvious to everyone, wasn't it? Oh, here you go. There's your 2. There's Summersoft. It's kind. So the question is, how can we detect it? How can we detect that it's MP raw code? That's really interesting. Because at some point, you know, let's just, right, because at some point it is made into a proper function. And we do long live it at that point, right? Huh? Where am I at? Oh, but we're actually cloning it. Because the const table for code.py is still living. So this is another issue. I think. If we continue again, where? I thought that's where we would want to be. So we slept once, we slept twice. Yeah, so the question is how do we know what entries in a const table are? Because they don't have types. I'm trying to remember. I looked in that ages ago. So it's still over there. So now we have, this is interesting. So this is not one of the issues that I was trying to fix, right? But it is this sort of like I didn't long live it sorts of stuff that sticks, that is long lived, that sticks around, that does cause that heap fragmentation. The other interesting bit is that we could actually try to free it once we're done with it. So like 299A0 is the const table, and the stuff in the bytecode is ordered. So the moment that we executed the bytecode, yeah, it's not worth it. Because like, if we know we're the main code and we know we've run past it and we're never going to use it again, we could delete it. But that's a big if. Oh, you know what? And now my boundary for what's long lived is wrong. I was like, why isn't these three things long lived? So, well, let me just fix that. Like, that's a huge pain. I'm going to keep making this mistake over and over if I don't just fix it. Where did I put that? So I want long live start. And it's load pointer, MP state context. What was it? And dot 200 and something. 272? Really? You remember that? GC. All right, let's see. Ha ha ha, Summersoft wins again. 272. If I could type the right numbers, we'd be set. Okay, that's what this is. So I think if we did an obj jump as well, we would be able to get the layout of the struct. The MP state context struct, but I haven't. I don't have time for that. All right, let's see if it works. 272. I can't believe you remember that. That's awesome. No wonder you're so good at getting stuff done. Try not to cuss. I cuss all the time, though. Okay. Hey, look at that. It's pink now. All right. Well, that's super interesting. I wonder... there's an issue. That's an issue. If somebody wants to figure it out, be my guest. This is interesting as well. I wonder what is this number in hex? I think, can I copy it? No. This SVG viewer thinks I want to drag. Okay, well that's all long-lived, which is great. We're just leaking this stuff. And these pointers could be a problem if we happened to be all right, so do people like what I'm doing? Do you want me to continue? Oh, we have that other issue that I will look at. Do you want me to keep doing it this way? 15E0. Oh yeah, you had to like copy it off my screen. I don't know what that is. It's like... Huh. I know Summersoft is still there. Sedacious turned into a pumpkin. I could do that. That makes sense. It is Friday afternoon. I think I'll just leave it running. I'll be right. I just have to go pee and then I'll dig into this other issue. I kind of want to see... yeah, I just want to hammer it out too. I think this type is long-lived though, so I'm not worried about it. I don't know exactly why it is. But it looks right. So we'll go with it. We just won't do the attributes automatically. It must be that it gets caught by the same one that does the imports. That's interesting. All right, I'm going to mute and then I'll be right back. All right, can you all hear me? All 7 of you? Sweet. Thank you, Melissa. Okay, let's put a bow on that one. We'll leave all, I think. Sweet. Mr. Certainly is here still too. I hope you're doing something else and not just watching this. Okay, let's do this. Let's just copy this straight away. Let's see where I'm at. Check my breakpoints. Disable 1, monitor reset, continue, turn it on. Uncomment this class definition and listen to the sound not playing. So let's see here. So let's put one here, and one here. This could be pretty interesting because the audio stuff has kind of background tasks that it does, and it might be snagging a copy, and the copy's not matching anymore. But I need a WAV file. Otherwise, it's not going to get that far. If you didn't realize, you're only seeing, well, you should be only seeing the top left of my screen. I have a WAV file called strange.wav. Do you think that'll work? I know I have some test files in here somewhere. I searched for .wav and you're giving me PDF files. That's not what I want. Oh, geez, that did not work. Here we go. Oh, I'm gonna have to get the sample rate right. 16 kilohertz, 8-bit. And it's called Cplay 5.1, 8-bit. Kilohertz. I bet that's mono. I don't think any of this stuff is going to impact whether we have the issue or not. Sample signed as false for 8-bit. Alright. Screen it up. Channel count does not match. So this is the point that it's probably not playing. I don't know what I could do. Here we go. You want to know how I listen to audio? I use my Salier. So if we comment this out, pull up Logic. Let's put a print here. Okay, we hit save. Should be playing. Heyo! Let's listen to it, shall we? All right. Now, if we uncomment this class, hit save, and do the same thing, we get nothing. Yay! Thank you, qubits. I think it was qubits. Thank you for the qubist. Thank you for the reproducible thing. Okay, let's take a look at this. And I think what's going to be interesting is the difference between the heap layout before and after the class is created. So I think this is what we want. So we just save it, and let me get out of here so I can start breaking without breaking my USB. Label 1 on reset, continue, and then I'm going to do the dump. Now I want to take a look at it. This is going to be interesting. I don't know if I've ever actually looked at a heap dump of the audio when audio is in play. So it should be good. I know that we had some issues with running out of memory, so this will be very informative. All right, so here's what we've got. We've got a lot of temporary stuff, and then we've got a little bit of long-lived stuff. And I wonder if I can leave this tab open. So we can see here that mixers pointed to here, and then mixer, these are two buffers. These two big ones are the mixer buffers. So, and then we see sample goes to here, which is the wave file. And then the wave file has two samples as well. So these are native classes. One thing we could add is to the heap visualizer is we could actually add the ability for it to recognize these. And actually that would be really cool, because if we could look up the structure of a struct, the structure of a struct in like the obj jump or whatever, we'd be able to get MP state context, and we'd be able to get all of these native classes like the wave file and the mixer and stuff as well. Hi, Gigahertz Coder. Welcome. We're working on CircuitPython. Let me know if you have questions. And then what we can see is this is our code.py. Again, the stack points to it. And then its const table has, we're debugging an issue where if you play back a wave file, it works. But if you create a class between when you set up the wave file and when you try to play it, it doesn't work. So we're trying to figure out why that is. It has to do with what happens when that class gets created. So the other thing we want to keep track of is that now that I think about it, there's this, and my guess is that it's related to that. This is on a Metro M4. It's a SAMD 51. I think Summersoft or Mr. Certainly could, or Melissa could dump you a link if you want to see that. But yeah, this is on the, I'm doing this on the 51, on a Metro M4 is what I'm using. So we're going to want to take a look at what happens around this stuff. What may happen is that we see 2 copies of it, and then that would be bad. So I'm actually going to see if I can... Wait, there's probably a way that I can rename it. Let's look at the source here. Output directory. Heat viz. And it gives me... Yeah, I could just move these two. I'm so lazy. Repos. CircuitPython. I'm debugging the firmware. Heat viz. Rename. Before. Okay. It has been renamed. So now what we're going to do is we're going to go to the next breakpoint, which, if you're following along, this is our test code. And our breakpoint is every time we hit a sleep, we're hitting a breakpoint. And so we just looked at the heap here, and now we're going to let this class stuff go, and then we're going to take another look at the heap. So let's dump. And take a look. And this is the old or the new version now. So let's just pull them up again. That looked pretty similar. Huh. It's not nearly as interesting as I... Oh, no, that's the before. That's why it looks the same. Oh, look at that. That looks bad. That looks quite suspect, doesn't it? And the reason that I say that is that we now have pink here and here, which we didn't before. If you remember, we just have 2 of these. So we still have 2 of the buffers. But I think what's happened is that we've duplicated, yeah, if we look closely, we basically cloned this one with this, which is definitely not good. So what would be happening is that if we look at the reference, let's see. So whatever this is referencing the old version, while our sample is now different. So that's quite bad. And I have a feeling I know why. I have a feeling what we're inadvertently doing is we're making everything in this table long-lived, which is not good. So if you call long-lived on an object that it doesn't know about, like a native object like this, it will only do the top level. It won't do the bottom ones. So yeah, that's a problem. What I'm curious about is if we get called with that. So let's go into our GC long-lived. Make function long-lived. Make property long-lived. Make dictionary long-lived. Update all the references so we reduce the chances of old copies. Make object long-lived. If it's a property, function, string or bytes, a type. Types are already long-lived during creation. So this is supposed to be a stopgap, in that we don't double scan something. We were having performance issues, and Dan found that. Let's just say if dict is equal to mp state vm the dictionary should be, what am I looking for? Dict main. Shocking. Let's do ASM breakpoint. So this is just like whenever you hit it, do a breakpoint. So I'll reload debug so that I can discover that it doesn't. MP state VM. I think I gotta. Include it. This is my longest stream yet, I think. Just hitting the 2-hour mark. And we're still debugging. That first one went pretty quick. Da da da. Although I'm surprised that we hit this because we haven't hit our first time sleep yet, which is also bad. So right. So I think I assumed that we're not supposed to make the main dictionary long-lived ever, was kind of my thinking. Because that would be right. Those are all the top level references, and we don't want to do that. So let's just try this. I bet this fixes our bug. And it might actually, as a consequence, mean that that first example of having the type actually long-lived won't work anymore. Which would also be interesting. So let's try it again. So we won't hit that breakpoint because we just deleted it. And we haven't done the class yet, so we don't care about this first one. Let's do dump and check it out. I guess we could see if the sound's played back, but what's the fun of listening to music? I don't know. Oh, and that looks better. So now we still have some interesting things about it. But we don't have the duplication here, which means that I imagine we're in a safe spot. The type still did get long-lived, so that's what this is. And then this is just a rogue pointer to the dictionary for it, which if we wanted to be nice about it, we could actually delete. Like we had an issue where we were long-living something, but with the pointer to the old version was still on the stack, and so we kept it around still, which was annoying. Yeah, so foo did get long-lived. Make mixer, a function, goes down here, did not get long-lived. The function itself did not, but the thing did. Long live CircuitPython. I know, should we just long live everything? That's interesting that this is here too. The file name's not being correctly referenced. I bet this is a copy of it. So we didn't run the GC collect yet. That might be interesting to see what this looks like after we collect. Let's just do that. So turned off or turned on USB. And then we'll do GC collect here. I wonder, so do we think that, do we think we should long live top level functions? That would kind of make sense to me. I mean, we probably want to long live functions in general. Is that always the case? I guess if you had one of those functions inside a function, you don't want to do that, because the context goes away. I should probably not mess with it. But like, it's all those little things that will fragment memory. Okay. Eject, detach, reset, skip the first break. First one we can skip, and now we want to dump. And rerun our visualizer. And let's take a look. Oh, it looks so much cleaner now, kind of. And then I can look here. Nope, not there. Heap layout. Yeah, so we deleted some stuff here. Over here, we're still... I don't know, my math on those boxes must be wrong. But everything else there is still nicely packed, which is good. And the fact that these are so far apart is exactly why you want to spend the extra money on an M4. It just makes it so much easier. Okay, so We haven't long-lived mixer, which we expect. We haven't long-lived sample, which we expect. It's interesting that there's no other references to it, because there are... They're not on the heap, though. I think that if we looked at the ports, I think we would find that it was in MP state context via MP config port. Modules. Did I go? I must have gone. Oh, no. Root pointers. Here we go. So we have playing audio. So my guess is that I guess we're not playing yet. I wonder if I don't know if my visualizer would know or not. But yeah, I think it looks good. I think exempting the top dictionary is what we would want. Yeah, if you have more questions about it, let me know, Mr. Certainly. I'm happy to explain the best I can. Should we see if it works? Should we see if we fix the bug? I mean, that's a pretty nasty one if we're moving everything at the top level. I would be interested to figure out. There might be more stuff we could long live and make things happier, but I guess I should fix these two bugs and be happy I fixed them. So let's run our test again. Disable 1. And we don't actually need to turn the USB on. We can just on reset, continue, go back to our Salier, and see that it is playing music. Yay! So we fixed the bug. Which is good. We definitely don't want to do that. The one question I have is whether we should mark it as scanning or not, but I think because mark it scanning, if we look back at this, we see that like it will return if it's scanning as well. But I think being explicit and saying like we do not want to scan the main dictionary, or we don't want to do the main dictionary is probably clearer, actually. So this should work just as well. So let's just validate that this works too. Yep. Should I have used that Taylor Swift song as my demo song? I'm not like I'm playing it, but okay, that is 2 bugs down. It looks like type still got long lived. I wouldn't expect it to. But everything it's pointing to does. That might... let's add a couple more things to that. So let's add a hello. Nice to see you. And let's actually put something else, like a value equals 0. And now let's eject first. Try to be nice. Table 1. Second one again. Dump our memory, and let's take a look at it. Alrighty. So it looks like it is all long-lived still. We can see that hello points to this function that's long-lived. We can see init points to this and is long-lived. I still don't know what this is. You know, that might be a type, actually. Or it's globals. That's what we decided, wasn't it? I think we did it a while back. Where we printed the BC. This. 20297E0. Oh, that looks suspect. That looks like the number you came up with, Summersoft. 15E0. What is that? What is 15E0? I think what we actually want to do is we want to look at the ELF file. Yep. Ugh. It should be in there, right? It says hanging off the screen. You can see what I'm doing. Oh, you can't see what I'm doing. What I'm trying to figure out is what that is. Like, it is globals. That would be... So all the stuff with zeros is stuff that tried to get linked in but was deleted. So we're in RAM. So you can see the layout here. Flash starts at 4,000. I'll call it 4,000. It's not actually 4,000. But then the read-only data gets copied over. Let's see, where's my page down? There we go. It must be something from read-only data, like a... But then it's copied into RAM. Oh, I know why my grep didn't find it. I put the 0x too early. Dang it. It must be within something. There's a read-only data. So if you've never looked at a map file, this number is the address and this number is the length. So it's a way you can figure out like how big objects are, or yeah, I don't know what the or would be. It's a way to figure out how big objects are. Okay, here we go. 2015 E. Oh, look at that. It's pointing back into MP state context. Which must, it's probably pointing to dictionary main, actually. What was the... MP state context is 1580. So the offset is not 0. Why does it give me 0? I don't know. You know what will work? Python. World's best calculator. Oop. Oh, I didn't copy it over. You mean subtracting the number from itself is the same as 0? It's also 96. So what is the offset of MP state? Yeah. So that 20 is in decimal. So if we just guess, it's the main dict, right? Is what we... No? What was it? Dict main? Heyo! Look at that. Should we get it so it links it back up to there? I think so. I think we should. Ta-da! Exactly. I'm surprised that Twitch doesn't support ta-da. Like all good things, let's hard code it. Manual symbol map. Does that do it? I don't remember if it automatically puts there's an address mapping to stuff. Yeah, they confuse me too. I don't know how they work. Nope, that didn't work. Get it. Oh, I could put... I could put the hex version in if I wanted to. Auto name to name. Address to name. I don't know how it comes up with that auto name. Must be if it's a pointer or something. Let's just hack it. What was it? 0x200 015E0. Handy to have it in the Twitch chat. And that explains why we were long living. It still didn't work. Maybe we need to... I don't know. Doesn't matter. We know what it is. Okay, we fixed the bug. We're no longer long living through the main dictionary, which is good. Because we assume that the main dictionary is stuff that's changing. Like that might get reassigned or something. So like if you had like a variable hello with 2 strings and you say like hello equals this, and then later down say hello equals that, like you'd end up long living the first thing and then you delete it, leaving a hole in your long lived, which is not what you want. You know, I guess I should let this go full circle. I was like, let's see if there's any other bugs to find, but I think a better way to wrap up is to actually send out some PRs, because that's an important bit as well. So I'm going to, I'm on a branch of, sorry, reading the chat. I'm on a branch that was already merged. So I'm going to fetch Adafruit and I'm going to actually check out. So this is what I mean, I've already made the changes, but I haven't committed to anything yet. This is my process for if I'm starting something new or I'm getting to the point that I want to do the first, like commit to something. I'll do git checkout Adafruit master. And now my git status thing really is in my fingers. The DHCP stuff, it's just a weird thing that I don't actually mean to fix. There's an issue for that with context that I'm just not going to deal with right now. And let's see. I could do this as 3 PRs, or I could be bad and just do it as 1 PR. I think what I'll do is I'll do it as 1 PR, but I will do it as separate commits. And then maybe Summersoft wants to review it for me too, since he's still in chat. And we can actually capture it live. Oh, I should make a new branch. Melissa could do the review, or anybody in the channel could do review for me if I needed to. Okay, git add tools, git commits, fix up heap analysis for dynamic heap location. It was originally, we used to just like hard code the heap as a static thing, and now we do it dynamically. So I fixed that before the stream. Don't long live class attributes. Because they may have been lit. Because when they are added later, they are also referenced in the main dictionary. The other thing to do would be to actually change the main dictionary. And then you can say fixes 1218, I think. So that will automatically close the issue once it's merged into master. Never long live main dictionary. Change often. Fixes 1443. I didn't change any translation strings, so I don't need to run make translate. I'll push a new branch. And now if I go back here, it should tell me I just pushed. Now I can compare. Bugs. Milestone 4.0. Add Taylor Swift to the PR. She does code reviews? That's awesome. Cool. Long live issues. I'm gonna add all of you. Nope. Y'all aren't collaborate. Only Summersoft is a collaborator at this point. Let me double check. I tend to like put debugging stuff in the code, so it's good to make sure that I didn't leave too much of that in there. I don't really care about the Python script, but the other stuff I don't want to do. Okay. That looks good. We won't actually be able to merge it for another half hour or so after Travis runs. But I'm actually not too bad. I'm getting hungry, but if I have bad code, she'll write her next song about me. I'd love to have a Taylor Swift song about me, even if it is bad coder. You can't merge anyway? I bet you can. If you came up as a reviewer. I mean, I can merge it after you approve it. But if you can approve it, I assume you can merge it too. Okay. Should we just take a look at the bugs and just see if there's one more we can't knock out? Crash into hard fault handler. This port in and port out constructors return none is really easy. I don't know French, so I can't help with that one. What's this one? Oh, this is a hallowing display IO thing, which I've been changing a lot. I'll do this separately because that includes display stuff. Factory deliver main doesn't work. I'll look at that later. This I don't think is an issue anymore. I gotta go through these. This I don't think we could fix. I don't think we could reproduce it. With the Hackaday Super Conference badge code. Could try that later. M4 Express can deadlock on certain complex import chains. I'm actually kind of curious about that. This one I just fixed. Moving a directory into itself doesn't raise an exception. That's fun. This one's easy too. Flush keyword arg. Should we try that import chain one? I think it's, since we're doing heap stuff, it might be interesting to, I think it's a bunch of code. And I don't think it should crash anymore because I've added checks to make sure that we don't overwrite stuff. Removing everything above line 37 in this should trigger at least the runtime error. It rsyncs over the KMK folder. Oh, that's complicated. Make. I think I do have a fork of this. Yeah, I'm already got a fork. What the heck? So the -o is for the name of the origin. I like to name all my remotes the same as the... What am I doing? trying to get as close as I can to what these instructions say. These instructions and these other instructions. This is just on master. I guess I could just check out their master. And then make. Thanks for the review, Summersoft. Hopefully Travis works quickly. Okay, mount point. Are we mounted? Nope. Oh yeah, if my like video feed, like my camera feed cuts out, it's probably because. Oh, hold on, let me. This is not gonna be happy. Maybe my breakpoints are off. Must have been past it or something. Whoop. Volumes. CircuitPy. I don't know. I don't have a key map. What's that do? Failure. They moved a lot over. Oh, you want to see it? Thanks for the heads up. I'm just rsyncing lots of stuff onto my CircuitPy drive. Maybe. Let's see. This is kind of interesting. Look at that. We crashed into hard mode. I was mem copying somewhere I shouldn't have been. Ooh, that's a doozy. That is not helpful. Source. Destination. Huh. backtraced this hose, which sucks. Do I have the micro trace buffer on? That would be amazing. Oh no, I'm on the M4. I don't have micro trace buffer on the M4. Micro trace buffer is a running log of where the program counter is, so you can actually go back and see what it ran before it crashed. It's amazing, but I haven't figured out how to do it on the M4. I only know how to do it on the M0. And this is exactly the sort of case that I would need it in. Let's just take a look and see if we crash here. And we don't. So it was in the file copy that we crashed. Well, we could see if we crash again. Sorry, I'm kind of stalling because I kind of want to merge on the live stream. No space left on the device. It's so gigantic. Why is there no space left? Maybe the WAV file? Delete. We don't need that. Ah, we crashed already. And it's just as useless. That's unfortunate. Anybody have ideas? Should we just see how Travis is doing? Travis, save us from fixing this bug. Like, I know it's a mem copy. Melissa says, check Travis. All right, let's check Travis. We're 13 minutes in. We're about halfway. They take about 24 minutes. So one thing I can think of is adding a sanity check to the length of the mem copy, because it's optimized out, but if it's super long, it would be an issue. We could also look at the registers. So this is in reset to safe mode, which we don't want. So where were we in? So we're loading from R1. That's when it failed. So if we look at the registers, it was 2,891, which should be fine because that is in RAM. And we're putting that into R4. Ugh. This sucks. These are like, I thought that the heat bug was hard. Like, this is a much harder bug. Like, not having not having a stack trace makes it really hard. And it's probably a race condition, because we're just copying a bunch of files over. And so it's probably a race condition in terms of copying large amounts of files over. I don't know, maybe we all just pretend we didn't see it. There's infinite bugs in CircuitPython. We can just leave this one where it is, right? Are there any questions people have? I'm amazed that you all are still watching, all 7 of you. But if we have another 5 minutes or so on Travis, maybe I can answer any questions about anything you saw, or yeah. Summersoft says, what hard fault bug? I didn't see anything. Didn't see nothing. Exactly. See, that's why I kind of added safe mode on a whim, and it's turned out to be really, really handy, because safe mode will save you. Although this is an interesting hard crash, because you could still do it, because the idea with safe mode is that it starts back up without running user code. But this is a case where we're hard faulting due to copying files over, which is not user code. So we actually don't potentially save ourselves. But yeah, that's kind of a bummer that it like the stack is all corrupt, which means we're copying somewhere where we shouldn't, probably repeatedly. Well, I'll have to let my brain chew on that one. What other bugs? We can classify issues with no milestone. Driver, yes. That would be awesome. But it's not for 4.0. It's a driver library. I did look at that, Melissa, actually, that it's a single color. I do want to add support for single colors in not too long. This is WizNet stuff. Okay. I'm not going to put that on 4x. I don't really like to have bugs that don't have a milestone on them. Tooling bug. If you didn't realize it, long term is the catch-all. Bug. Tooling. Driver. Oh man. Multiple virtual keyboard devices. Definitely long term. It's not a good first issue. It's tough. Ooh. For KMK, it's running ampy in the make file. Oh, it could. It's running ampy? It could be a memcopy issue in the CDC stack. That is interesting. That's also terrible. I'm not. In the issue, it said that it was rsyncing it over, so I assumed that it was. It's. What? It's running ampy? Is it actually copying all the files over with ampy? Like, why am I giving it a mount point if it's using ampy to do it? Ampy delay. Oh, it's resetting. Oh, I bet it's not running that. We can see though. I know. It does look like they rsync all the files over, and it's my guess that that's when it's happening. Concurrency is really hard. I was too quick. Hey, it didn't crash. I don't know what this... Oh, there is a user key maps. Huh. I had to define it, but they give me an option. Heyo, that worked. Invalid wave file. Oh, it copies over a main, doesn't it? Yep. Rename audio test. I have a bad habit of leaving my test files on the device. But main is not doing anything. It doesn't seem right. Import sys def main. It's working. Is that because I chose no op? Maybe. That one. Yeah, I'm trying it and it's... I don't know if it's changing my main at all. Nope. How is this supposed to work? Oh, it's copying my key map to main. Now it's 4 kilobytes. That sounds better. Ha! Table flip. It's running. Ooh, ooh, ooh. You know what we should do? Let's stop that and eject. And then we'll take a look at RAM and then we'll be done. Since that's the theme of the day. Ooh, it's like doing GC stuff. Oh, no. No worries. It's been a while since there we go. This will probably take longer to render than before. Is it in here? I went too far over. I hate how the history is different. If I had my way, it would just all be one. Oh yeah. Look at all those objects fly by. Hopefully it won't crash. The script used to crash from time to time. Let's see how Travis is doing well. Ayo. We're all green. Summersoft, are you allowed to merge? Do you want to try it? Well, it decides how to place everything in the giant chart. We should keep track of like the age of everything. It might just be garbage. No, generated something. Look at that. Wonderful. Oh, I wonder if it wasn't done. It's not quite valid, but it's okay. Let's start here. Talk about excitement. And it looks like it didn't even finish rendering it. It just crashed. This is the power of the M4. Let's take a gander here. Man, that pink on salmon is terrible. Lots and lots of strings. Yeah, maybe we shouldn't check that pink in. These are functions. The question is, what's all the stuff in the middle, really? I mean, this is not very helpful, but let's take a look here. Oh, no. Because it was not valid, it didn't. The extension that makes me able to zoom in doesn't work. No draw heap layout, I think is what it is. It might work better if I just try to do the one. It's gonna take a while again. Nope. Okay. Merge. Yay! It's weird that you can't merge it. I don't know if I have another SVG viewer. Invalid char value. I could fix it manually. I just want to see it. I just want to see it. Heap. Ownership. SVG. 16. 8. 2. Command K and Command L. I'll just put a KL there. Hopefully it will be able to load. Look at that. All right, should we take a look? Oh, it's gonna be really slow. That's why this is interesting. And this is why small examples are great. So like we did before, we'll start with strings. So the way the QString pool works is actually like the least filled one is the first one, and then each one has a pointer back to the previous ones. So all of the strings, if we look in here, these are all the strings loaded last. And some of these weird characters, that fuzzy one is me trying to handle them gracefully. And then you can see that the darker ones are what a QString is, a number which is an index into those tables, and then those tables have indices into the continuous string. And then let's see, where do we want to start? I want to start way up above. Hopefully in like our dictionary table for everything. And if it's jerky to you on the streaming side, that's because it's jerky on this side as well. It's not a streaming artifact. It's a giant SVG. So these are our globals. And they go everywhere. I think this might be the largest chart I have ever looked at, because I haven't looked at many on the M4 and the other stuff. What's your RAM usage on your PC? I have no idea. The streaming's going okay. Yeah, I mean, like, how big is the file? It's only a 4 meg SVG. It can handle that. So this is why I have it be able to show you strings, is so you can start to get an idea of what everything is. All these blue ones are tuples, I think. All pointing to the same thing. So it is interesting to see that like this dictionary is not long-lived. It probably should be, but I think I long-live it and then things get added and it moves back outside. That's probably what these... Yeah, I don't have the names in there. But I wonder if I could turn off the edges. But basically all of these things in the middle here are the things that are like fragmenting our memory. And those are all functions and stuff. Interesting. That's really interesting. So there's, what you can see here is there's definitely room to grow in terms of reducing fragmentation by long living stuff. Is that some of this can probably be moved into this long-lived heap. And the long-lived side of the heap looks pretty good. Like it looks continuous. The blobs up at the top are just because I'm not wrapping the blocks around. They just go off the bottom of the screen. So that should be continuous still. But all of this is fragmentation here. So, all right. It's been 3 hours and 10 minutes of a continuous stream, although I did take a little bit of a break. To everybody watching, thank you for watching. I hope this was an interesting adventure, diving into how I fix things in CircuitPython and kind of give you an idea of the workflow for debugging heap issues. It's really great for figuring out why you're running out of memory. So if you ever have something where you're running out of memory, these are the tools that I would use to do that. And you saw the pull request process as well, which is great. So thanks again to Summersoft for doing the review and helping out. Maker Melissa, Sagittac, Jerry was on earlier. Thank you to him as well. So yeah, thank you all for watching. And we have our normal CircuitPython Weekly on Monday. If you want to be more involved, you can also join us on Discord at adafruit.it/discord, which is adafru.it/discord. With that, I will, I think I might try to get PS2 keyboard input working for a little while here. I want to do a standalone demo where I can type on my Model M into the CircuitPython terminal, which would be really cool. So that is really cool, but I'm not gonna stream that. I'm getting an overhead camera thanks to Adafruit next week, so I should be able to actually live stream my desk as well. So that would be neat. So before then, I'm gonna take off. I'm gonna take these headphones off and listen to some music, have a snack, and get PS2 working in CircuitPython. So thanks again, and I'll see you next time I decide to stream, whenever that is.